Greetings everyone, I am Prabhdeep Singh Sethi from Government College of Engineering Nagpur, Computer Science and Engineering, 6th semester, and this is a mini project, Metricity. So Metricity is about reducing electrical consumption by real-time monitoring of electrical appliances. We'll get to know how it works and what it is in the later slides. So let's move forward. So Metricity is a digital platform for real-time monitoring of electrical appliances. What that means is user would be aware of what they are consuming, how much electricity each and every appliance is consuming. So that's the huge plus point. It not only makes user aware of excessive expenditure, it also optimizes consumption and delivers data-driven controls. It has been observed that if a user has been made aware of their electrical consumption, it leads to 15% in reduction in electrical consumption, overall electrical consumption. This is a literature review, and these are some of the links that we have taken into consideration while formulating the idea. The first link being the most important one, which indicates that there will be a huge surge in the electrical smart meters. That means that the government is rolling out plans of converting the traditional meters into a smart meter, or changing the traditional meter into smart meter, which is a huge plus point in our idea, and we'll get to know why in later slides. So how we got the idea of actually doing this? There was a lack of real-time monitoring of daily electricity consumption. I can explain you this in a very simple example and a day-to-day example. The bill that we get, often the consumer feels that the bill that they get is not the bill that they should be getting. That means there is a surge in the electrical consumption which they didn't even consumed. That's what they feel. So there is no assurance to the consumers that the bill they are getting is actually the bill that they should be getting. Also, Indian consumers definitely lack data-driven control over their own electricity consumption. Even smart meters lack cross-checking support for consumption control. Smart meters will give the electricity units consumed at this instance, but not at the appliance level. It will give the summation of the whole unit consumed by the house. There is clearly an absence of a system for analysis of electrical usage. There is absolutely no mechanism for appliance level monitoring. These problems lead to wastage and theft of electricity with increased expenses. The scale of this is the wastage and theft of electricity is nearly equivalent to 3 to 3.5% of Indian GDP. That's a big number, and we intend to solve that problem in a way. There are existing systems which cater to these needs, but they even have their own limitations. Sense being, there is a system called Sense which caters to smart devices and appliance level monitoring. That is, if all of the devices in an Indian household are smart, you will get the same idea that we're talking about. But that is not the case in a general Indian household, where the majority of the devices are non-smart. So Metricity caters to both smart and non-smart devices, unlike its existing competitors, this being the major USP of Metricity. Also, Metricity provides cross-checking of the total device consumption with the smart meter reading, while also allowing device level appliance and room level monitoring. What this means is, as we have talked before, if the user gets assurance that the bill that they are getting is the bill that they should be getting, here that need is catered. How? If a smart meter reading is equivalent to the summation of all the appliance level reading by Metricity, that means the bill that they are getting is the bill that they should be getting. If there is mismatch in the two, that means that there is either a faulty device, a faulty appliance, or there is theft going on. So users are also aware of these things, which is a huge plus point. Now our problem statement here is, we intend to formulate a technological solution to provide real-time monitoring of electrical appliances, to provide data-driven control over consumption, and to reduce instances of excessive usage, electricity wastage, and theft of electricity. Our solution here is, we intend to give a digital responsive cross-platform interface named Metricity to provide real-time monitoring of electrical appliances. We aim to deliver appliance level analysis, simultaneous overall consumption by synchronizing smart meter with appliances as discussed before. In the future, Metricity will also be able to generate daily, weekly, and monthly reports using visualization and usage statistics. What that means is people would be aware of overconsumption before they even overconsume electricity. That is, Metricity will it is a data science and machine learning part of Metricity, which will be executed in the future. That is, users would be aware of overconsumption before even consuming that much electricity based on their past trend of electricity consumption and their current electricity trend. Metricity will be able to give users warnings of overconsumption in the future. That's by my side, and the later part would be carried on by Ameya Shahu. Thank you.
Technical design of Metricity. HTTP protocol, that is, request response model, is used between interface and server, whereas server and microcontroller communicate over MQTT protocol. The interface part mainly have three functionalities. First one, validation of user, request data to server, and sending request to change state of a device. Whenever a user tries to log in through interface, a request with parameter username and password will be sent to API hosted on server. API will validate user with respect to entry in database and return true or false according to validation. Second main functionality of interface is to request for device data. The data include power consumption of respective device, current state of that device, and total power consumption until that time. This request also fulfilled by accessing data from database. When interface requests to change state of device, that is on or off, API will pass a message with device ID and state to be changed to a background process named as pub sub client over socket. This process has two threads, one which receive data from API over socket and push receive message in a queue. Another thread has a MQTT client which will subscribe or publish data. If there are any message in queue, then this thread will publish that message on topic which is subscribed by microcontroller. This message transfer will take place through MQTT broker, that is Eclipse Mosquito, and as soon as state change message will be received at microcontroller's side, respective device will be turned on or off. Also, data published by microcontroller after every 5 seconds on a topic which is subscribed by PubSub client process on server. This is use case diagram of Metricity interface, consists of login module, daily power consumption module, appliance level monitoring, and monthly power consumption. Monthly power consumption is yet to be ready. On microcontroller side, a class Metricity device is there which is used to control device connected with microcontroller. Flow of program at microcontroller end. It is working asynchronously. For that, time object.h library is used. Timer of counters of device which is increment after every 1 second, which are on, and microcontroller publish data or MQTT topic after every 5 seconds. If state change message is received as subscribed messages received at topic subscribed by microcontroller, it will change state of that device.
As we have seen the technical details, let's move to overall working and its demonstration. Basically, working is divided into three main parts: data collection, working with collected data, and the interface. So the first step includes collecting data from devices and sending this real-time information to the server. The data will be in JSON format consisting current counter value and status of device, that is whether the device is currently on or off. Second step includes manipulating the collected data. This will be done using conversion logic for each device. The current counter will help in finding out the time for which a particular device was turned on, and power consumed by that device per unit time will find actual power consumed in real time. Lastly, coming to the interface, the final results will be displayed on digital interface in a user-friendly way. Now, here is the demonstration of our model. Let's begin the demonstration. We can see the dummy model, and this is the login page of our app. We will enter the username and password and log in. We can see the validation is false. Now let's put in the correct username and password. After logging in, we will reach to a home page, which will show daily power consumption of over all devices. And then we will next go to appliance level monitoring. Here we can see the air conditioner and television initially are 0 and hall light has consumed some units. Now we have turned on the hall light, and now we will turn on the air conditioner. We could see the hall light and the air conditioner have turned on, and now we will switch them off. Let's switch off the air conditioner as well. We will again log in to check today's daily consumption. It has changed, the daily consumption has increased. We can see the line graph as well. Here we can see the air conditioner units have also increased and the television remains the same as it wasn't turned on. Coming to the technology stack, the software requirements include, in the server-side technology, Python language, Flask framework to develop web API. These are the libraries to connect servers over MQTT, AWS EC2 instance, Ubuntu as the operating system on server side, Apache 2 as web server software, and Eclipse Mosquito as the MQTT broker. The cross-platform application is built using Dart language and Flutter framework is used, and these are few important libraries. Coming to the hardware requirements, the IoT kit includes ESP8266 microcontroller. Cloud-side hardware includes virtual CPUs with the following configuration and 1 GB of memory. The hardware programming part includes C, C++ language, and these are some important libraries. Application. Metricity has complete potential to be adopted in the current market scenario given the increasing use of smart and energy efficient devices. It is meant to keep a check on electrical consumption, which is prone to good reception as conservation is the need of the hour. So, if this is applied to real households, we could save tons of energy and hence save our electric bills as well. A few results of the experiments which were conducted are here. The simulated appliances showed the following readings when the power consumption was noted for 1 hour. Validation of the previous simulation was done using a 5-watt CFL bulb. Here are the results of the experiment, which gives the units consumed in 15, 30 and 60 minutes of time span. So, Metricity was able to demonstrate real-time monitoring using 6 simulated appliances and a 5-watt CFL bulb. When coupled with smart meters, Metricity's results will be useful in reducing consumption, costs, and in providing control. Thank you. This is Team Metricity. Team members include Ameya Shahu, Gauri Toshniwal, and Prabhdeep Singh Sethi.